So we know that tangent is sine x over cosine x, right? So that's a rational function. It's a fraction. So we know that there is a possibility for the denominator to equal 0. In this case, the denominator is cosine. And whenever the cosine is 0, the tangent will be undefined. So let's think of where the cosine is 0. Cosine of x is 0 at x equals pi over 2, 3 pi over 2, and so on, but also the negatives of these, so plus, minus, plus, minus. At these points, the graph of tangent has vertical asymptotes. And so if you look at the tangent here, right, this is what the graph of the tangent function looks like, all right? And you see there are asymptotes at pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2. These are the points where the cosine is 0, so the tangent is undefined. Okay, now, so what does the one cycle of the tangent look like then? One cycle of the tangent looks like this, okay? And so cosine and sine started at 0 and went to 2 pi. Tangent then, one cycle, that initial cycle, starts at negative pi over 2, goes to pi over 2, right? Negative pi over 2 to pi over 2. How much is the distance between them? Pi. So the period of the tangent function is pi, not 2 pi, right? That means, okay, everything is going to be based on pi. Okay, yeah. Because cosine is 0 at like pi over 2 and negative pi over 2, 3 pi over 2 and negative 3 pi over 2. Okay, now, so the general form of the tangent function looks like this. Okay, same idea, right? You got A, B, C, and D. Now, we just said that for that initial cycle, the vertical asymptotes are at x equals negative pi over 2 and pi over 2. Okay, so so to find where the asymptotes lie, we would have to do bx plus c equals that. Ignore this for a second. We're going to come back to it because we're just going to use a more efficient way to do this. Okay, let's talk about period. For sine x and cosine x, right? To find the period, we were doing 2 pi over b, right? Because the initial took a length of 2 pi. Now for tangent, the period is going to be just pi over b, okay? Same idea, but just pi over b. Okay, and then graphing it is pretty much the same. So remember how for sine and cosine, we were going from 0 to 2 pi, and we were putting bx plus c? Now we do bx plus c, but because that initial cycle goes from negative to positive pi over 2, that's what we put instead. Okay? Same idea, different numbers. All right? So, and that's going to be like the law of the land for the tangents. Okay, so let's take a look at this one. Locate the vertical asymptote and sketch the graph of tangent 3x. Okay, now look. What's A for this function? 1. What's B? 3. B is 3. So period is pi over 3. Now, for the asymptotes, we're going to do it all in one shot. We're going to do negative pi over 2 to pi over 2, bx plus c, so that's 3x. No, because it's undefined there, right? So we divide by 3, 1 over 3. Negative pi over 6, 3. Yeah, everybody's saying my 3's look like X's or 8's. No, because it's undefined there. So now, look, this is the graphing region, just like before. And also this doubles as the vertical asymptotes. So see how we found it all in one shot. So the vertical asymptotes are plus or minus pi over 6. Okay, let's graph this thing. Okay? Oh, no. I mean, for this one, it's going to end in the middle. But, okay, here we go.
Why can't we draw that line?
Hang on. Just give me a sec. Negative pi over 2. 1, 2, 3, 4. Pi over 2. I'm not skipping for this one because it's going to get too wide. But it's fine. What's smack in the middle? 0. What's this first one here? Negative pi over 4. Pi over 4. So now you see that that y-axis was in fact going to go there. Okay? Okay, now. At negative pi over 2, there is a vertical asymptote. At pi over 2, there is a vertical asymptote. If you don't put the asymptotes there, it is not a tangent graph. And I can't give you full credit. Oh my gosh. Okay, so I'm so sorry. I don't know why I'm rushing. I'm so sorry. Okay. It was pi over 6 and 6. So what would this be? Pi over 12. Pi over 12. I'm so sorry, guys. No, because it'll be like pi over 6, and then half of pi over 6 is pi over 12. Yeah, the simplified version. Okay, now look. The center point is always going to be on the axis. The one to the right, okay? Look at this here. Tangent goes to the right, it's 1. To the left, it's negative 1. So the one to the right, it's going to go positive 1. The one to the left is going to go negative 1. And now to graph, it's going to follow the asymptotes there. We curve and we go down. Okay? It's not necessary. Now look. Let's see how I came up with all this, right? How did I know that that was going to be a 1 and so on and so forth? So let's do this. Let's plug some points in. We have x and y. So one of my x's here is pi over 12, right? So let's put pi over 12 here. Y equals tangent 3 times pi over 12. How much is that? Tangent of pi over 4, which is what? 1. So do you see how this is at 1? Right? Okay, so what if I have negative pi over 12? Tangent of 3 times negative pi over 12. Tangent of negative pi over 4. How much is that? Negative 1. All right? So no matter what you do, it'll always resort to pi over 4 and negative pi over 4s. Okay? And then tangent of 0 is 0. So this is how we graph a tangent. You have to remember, okay? Now let's remember this. Let's go back to the initial diagram. This region here, from 0 to pi over 2, what quadrant does it represent on the unit circle? The first quadrant, right? From 0 to pi over 2, it represents the first quadrant. In that quadrant, is tangent positive or negative? Positive. That's why this goes up. What about 0 to negative pi over 2? What quadrant is that? Oh, I got 2, 3, and 4. Which one is it? 0 to negative pi over 2. Which quadrant is it? Fourth, right here. 0 to negative pi over 2. That's in this quadrant. Is tangent positive or negative there? Negative. That's why this is negative here. And so when I come here, this is going to correspond to the first quadrant. So it's positive. This is going to correspond to the fourth quadrant. So it's negative. Okay? All right. Let's do another one. Okay. What's the period here? Pi over, what's B? 1/3. So 3 pi. Okay. For the asymptotes, we go negative pi over 2, 1/3 x, pi over 2. Okay, what am I going to multiply by here? 3?
Oh, that's a 3 on the bottom?
Oh my gosh, my 3s. I got to fix my 3s. Okay. So, negative 3 pi over 2, x, 3 pi over 2. Okay, so here we go. Okay, negative 3 pi over 2. 1, 2, 3, 4, 3 pi over 2. What goes in the middle? 0. And then what about here? What do the other ones get? Yeah. So what's halfway between 0 and 3 pi over 2? 3 pi over 4. And negative 3 pi over 4. Okay, let's put asymptotes. Because what's a tangent graph without asymptotes? Nothing. Okay, 0, 0. Center is 0. Now, okay, so the asymptotes here were x equals plus or minus 3 pi over 2. Now look, A is 2 here. That's a vertical dilation. That means to the right, it goes up, but how much up does it go? 2 units, and here, down 2. Okay? So that's the 0, and then also like say this is 1 and this is 2. If it's symmetric like this. Because, you know, things are not always very simple. I mean, I don't know. Don't quote me. Okay. Because if there's a phase shift, then not. Yeah.
Is there ever going to be a
No, because I'm only having you graph one cycle, one period. Okay. Reflections and translations. Okay, what's the period for this one? 4 pi. So this is negative tangent. This is the same as 1 over 4x. So 4 pi. Okay. So negative pi over 2. And then here we put x over 4. Pi over 2. What do I multiply by? Okay, so what do I get? Negative 2 pi. 2 pi. Also symmetric because there is no phase shift. So negative 2 pi. 1, 2, 3, 4, 2 pi. 0 in the middle. And then these are going to be pi and negative pi. Okay, so the asymptotes are x equals plus or minus 2 pi. Okay, center goes on the 0. Now, there is a reflection. So to the right, where do I go? Down 1. To the left, up 1. Don't forget your y-axis. Yep. Y'all ready for phase shift?
Yep.
Phase shift. Okay. Oh, this one has a reflection and a phase shift. Whoa. What's the B for this one? What's B? 1. So period is pi. Okay, so phase shift. X plus pi over 2 equals 0. X is negative pi over 2. Okay, so negative pi over 2, and then in the middle I put x plus pi over 2. Okay, subtract pi over 2. Ah, 0? No, negative pi. Right? X, 0. Fabulous. So now the asymptotes are x equals negative pi, x equals 0. Right, Shayna? So now it's different. Yeah. Okay, so here we go. Negative pi, 1, 2, 3, 4, 0. Asymptote. What's smack in the middle where the blue is? Negative pi over 2. What's this red one? Negative pi over 4. And then what's this black one? Sure. Okay, that's a 3, not an 8. 3 pi over 4. Okay, now look. Center still on the axis because there is no vertical shift. To the right, up or down? Huh? Oh, yeah, I'll show you right now. Down 1 because it's a shift, and then up 1 here. So this looks like this. Now, I need to put the y-axis. The y-axis is going to coincide with the asymptote. So just put it here, and you can put them like a hairline away from each other. Make sure that both y-axis and asymptote are visible to the naked eye. Okay? Because the y-axis always goes at x equals 0. Okay. Ready for cotangent? Cotangent. Okay, so cotangent. Cotangent, remember, is cosine over sine. So cotangent is 0. I'm sorry, cotangent is undefined when sine is 0. And where is sine 0? At 0, pi, 2 pi, negative 2 pi, and so on. That's where the cotangent has vertical asymptotes. So now look, the period of the cotangent, right? This starts at 0 and goes to pi, right? Because sine is 0 here, sine is 0 there. How long is the period then between 0 and pi? Pi, also pi. So it's similar to the tangent, also pi over b. But always a plot twist. Here we go. Okay. From 0 to pi over 2, right, coincides with what quadrant on the unit circle? 1. Is cotangent positive or negative there? Positive. That's why this is positive. From pi over 2 to pi corresponds to what quadrant on the unit circle? 2. Is cotangent positive or negative there? Negative. That's why it's negative here. So, okay, whereas tangent went up to the right, cotangent goes down to the right. Now, don't ever say it's the reflection of the tangent Because no, one goes from 0 to pi, one goes from negative pi over 2 to pi over 2. So that's blasphemous to say one is the reflection of the other. Just because they look that way, don't be disrespecting the functions like that, okay? So let's do it. Yay! So for this, we're just going to go from 0 to pi. Whew! More things to remember. Yay! But if you know that they correspond to the quadrant, then we just, or if you know, like, it's because where sine and cosine are 0. Okay, let's do this. What's the period of this cotangent 2x? Pi over 2 it is. Okay, so here, we're going to go from 0 to pi, and we're going to put 2x. Divide by 2, divide by 2, divide by 2. 0, x, pi over, oh no. The asymptotes are x equals 0 and pi over 2, right? Because we're going to go from 0 to pi over 2. Oh, I want to make that straight. What were you saying? No, it was pi because we went from 0 to pi. Yeah. Okay, 0, 1, 2, 3, 4 to pi over 2. What's smack in the middle? Pi over 4. What's before it? Pi over 8. And then what's that one? Okay. So this is 3 pi over 8. There are two ways of doing that. One is halfway between red and black. So half of this plus this. Another one is if each one is pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8. Right? Okay. Yeah. X-axis is there. Y-axis goes here. Asymptote also goes there, because why not? Asymptote goes here. Oh my God, I love graphing functions. Center point on the 0. To the right, where do I go? Up or down? Down. So here I go up because math is symmetric. Here we go. Your very first cotangent function. You can give yourselves a hand. Come on, that is worthy of a hand. Okay. Okay. Oh my gosh, now you're asking me to choose between my children. I can never do that.
You invented all the functions?
I wish I did. Okay. The parabola is special because it's like the beginning for students. It's the gateway. Mm-hmm. That's why I love teaching Algebra 2 so much. It's because that's where students really start to get into like the real math, right? Between August and June, there is so much that happens in Algebra 2 students, so much growth. That's why I love teaching Algebra 2. And I love teaching Precalc because of like all the exciting things that are in there. So really, like you really can't choose. You really can't choose. Algebra 1 is, okay, amazing because you know what? It's like a blank canvas. And you can just like teach them the way like they need to be taught. You know what I mean? There's something to be said for that versus like getting a class where everybody learned Algebra 1 with another teacher. Oh my God, so many habits. Oh my God, don't remind me of those boxes now. Okay. Yeah. What do you mean? Like when? Like in the 1500s?
No, but like in not our generation. Like, is it new curriculum?
Oh, no. Precalc has always been there. I took Precalc. My parents' generation took Precalc. Oh, Noah, do you want me to show you my transcript? Okay.
If you could print that out for me, that'd be great.
Yeah. Huh? Oh, how do you think I did?
Straight A student?
Okay. Okay, yes.
So for the tangent graphs, the cotangent graphs, when you're trying to find the asymptote to 0 and the negative to 0, And then for the other one, you do, and then one before you did pi over 2.
Negative pi over 2 to pi over 2, yeah, the tangent.
But these are the normal ones. It's just for like
Yeah.
the cosecant.
Yeah.
Those are just the ones
Okay.
multiplied.
Yeah. Okay, now, cosecant and secant are reciprocals of sine and cosine. So, cosecant is 1 over sine. That means it has asymptotes wherever sine is 0. Okay? And then it has minima where sine x has maxima, and maxima where sine x has minima. We'll get into that. Secant is 1 over cosine. So secant has asymptotes when cosine is 0. And then it's the same with the maxima and the minima. So the best way to understand how to draw one of these is to start with their reciprocal. So to draw a cosecant, we first draw a sine function. You see here the dotted function is a sine function, right? Now, this sine function is 0 here, 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 and here. At all of those points, the cosecant will have asymptotes. Okay? Now, when the sine function has a maximum, the cosecant has a minimum. You see that? That U shape is a cosecant. Where the sine has a minimum, this has a maximum. So what we do, hang on. We draw this and then we just draw the U here and the U here. Now I'm going to wait to graph one before I take questions because you'll see, okay? Because I know all the questions you guys are going to ask. Now, for the secant, I draw a cosine. Can you see this is a cosine? Because at the 0, it starts away from the axis. So this is a cosine. This is 0 at all of these points, so I draw asymptotes at all of those points. Then, same situation, a U-shaped graph. And so now, everything is inverted, right? So first of all, the domain for the cosecant is not all real numbers. But then more interestingly, the range is very different. Because for sine x, right, y equals sine x, the range is from -1 to 1. For cosecant, it's opposite, right? So for cosecant, the range is, look, -infinity to -1, and then 1 to infinity. It's empty in the middle. Okay, so let's just graph a couple. This is how it looks in its like full glory. Look, it's empty in the middle, and then it only exists from -infinity to -1, empty, and then 1 to infinity. Okay, let's graph one. Look, to find the asymptotes, we're just going to graph and then read off the asymptotes. Okay? So here we go. Period. We want to graph y equals cosecant 2x. So b is 2. The period is pi over 2. No, it's not. It's 2 pi over 2. So pi. Yeah, as the sine and cosine. We're going to do a little summary right now. Okay, so only for the very first one, I'm drawing over 2 periods. So look at this. I already drew a sine with a period of pi, right? You see that it goes from 0 to pi? But then I also drew a second period to the left just so we have a little bit more like practice. So you draw the sine function just like you did in the last section. Then wherever the sine hits the x-axis, you draw asymptotes. Everywhere. Don't discriminate. Everywhere.
Would you recommend drawing the sine?
I so do. That's how I do it. Draw the sine function first. And then, so now we do this. Now, okay. So now the secant function, I start from here and I go up. So you got to make sure that they meet at that maximum and minimum. There can't be any gaps. No. Because you did the points for the sine, right? That's how we graphed the sine. We're not just going to eyeball. Okay? Okay? All right. Okay, here we go. The purples are technically the cosecant. So now, where are the asymptotes here? Just read it off of the graph. X equals 0, x equals plus or minus pi over 2, x equals plus or minus 3 pi over 2. Okay? Oh, no. Oh my God, sorry. Pi and 3 pi. I'm sorry. Yeah, that would have been the next one, but yeah. Okay, pi and 2 pi as well. No, there is no asymptote at pi over 4, right? Yeah. Okay, next let's draw a secant. So for a secant, we're going to do a cosine. Okay, so the period for this one is going to be pi again. So we're going to go from 0 to 2x, from 0, 2x to 2 pi. Why can't I erase? Okay, I can't erase. So 0x pi. Okay, so let's do this. Okay, the 0 is going to go here. Okay, so this is 0, 1, 2, 3, 4 pi. So this is pi over 2, pi over 4, 3 pi over 4. Okay, we're going to graph a cosine here. Cosine starts away from the axis, right? So I'm going to graph negative cosine 2x. Cosine starts away here. Then I go up here. 1, 0, negative 1. There. Okay. Asymptote. Asymptote. Now, to do one period, you have to have 2 complete U's, not 4 half ones, 2 full ones, right? So in this case, like this would have been a complete period. So let's do that here. This will be 1. Now, the way this stands, your other one will not be complete. So what you have to do is you have to pick one side, either the right or the left, to complete it. So I'm going to pick the right one. And I'm just going to complete this, bring it up one more. Okay, so now there is a new asymptote there. Yes, you do. What will that be? 5 pi over 4, right, Zachary? 5 pi over 4. Okay? Now, point, graph. Now it's a complete cycle. Yeah. Yeah. Oh my God. So pi over 4, 3 pi over 4, 5 pi over 4. Okay, why don't we summarize? Let's summarize all of this. Let's summarize. So what we have is, okay, y equals sine x, y equals cosine x. The period for these two is 2 pi over b. And then the region goes from 0 to 2 pi, right? Okay. Okay, now, then I have tangent. The period is pi over b, and I go from negative pi over 2 to pi over 2. Then I have cotangent, pi over b, and it goes from 0 to pi. All right? Memorize that.